Hello, my name is Junpei Nishikawa from Shizuoka University, Japan. This is a pre-recorded presentation for the 2020 International Conference on Cognitive Modeling. Today, I'm going to talk about the cognitive modeling of errors during the Japanese phonological awareness formation process. I'd like to begin with background about our study. Language development is influenced by both innate and experiential factors. A prominent example of such convergence can be found in phoneme segmentation, which is one of the linguistic components. Infants initially have opportunities to divide a sound into various types of segments, like syllables or morae. Though as they grow up and master their language, they find it difficult to recognize phoneme segments that do not belong to their mother tongue. This developmental process is partly attributed to an ability which enables one to intentionally pay attention to phonological aspects of oral languages. This ability, called phonological awareness. The purpose of this study is to model phonological awareness using ACT-AL. We focus error occurrence and suppression factors that are related to the phonological awareness formation process. To examine this, we map innate and experiential factors to memory retrieval mechanism of ACT-AL. In this research, we focus on Japanese word game. This is because there is a clear connection between Japanese phonic elements and written symbols, which is considered to be advantageous for modeling using a symbolic cognitive architecture. Now, let me explain the model. This model includes two agents. Agents keep a word game going by taking turns providing words. For example, Agent 1 answers ringo, meaning of apple. The end model of the answer is go. Then, Agent 2 retrieves the word start with go. The dashed area is the agent's declarative memory. It contains a network of molar and word knowledges. Here, we set knowledge similarity as an innate factor. We expect that this will allow to observe errors, such as the confusion of similar morae. We also use the effect of learning as an experiential factor by setting a base level constant. We expect that this will help to retrieve correct knowledge and suppress errors. We run a simulation using this model. Here is the result. Results for each similarity weight are compared according to the rate of correct answers. Correct answer rate is defined as the ratio of words suitable for the word game rule from among all the words that were provided during the task. It can be read that the similarity setting causes errors and a low correct answer rate. The results are also compared according to the effect of learning. The horizontal axis represents the value of base level constant. The graph shows an increase in correct answers as the base level constant increases. The above can be summarized as follows. This study shows that the phonological awareness formation process can be modeled by mapping it to a generic memory mechanism. We model the innate factor as knowledge similarity, and the experiential factors as effective learning. It is noted that the increase in the correct answer rate is derived from the comparison of the result for each parameter setting. It didn't show that the learning occurs through the performance of tasks. Therefore, it is necessary to further examine the interaction in which the learning effect can be expected to operate. Thank you for your kind attention.